Hello, welcome to you all on Glecta platform. How are you doing? Hello, Danis. Physics is your favorite subject. That's great. All right. So as you know, we are a big team and we provide excellence in learning. You all know that, right? We have all sorts of courses here, 11 plus, GCSE, A level, and all of them, right? Most of the boards syllabus are covered here. So today's physics session, and we are going to talk about energy. Hello, Michael. How are you? Yeah, so in energy, we are going to talk about GCSE topics, right? And in GCSE, Advait. Hi, Advait. How are you? Good, good, good. So, let's begin with the list of topics that we are going to cover in this session. Kinetic energy store, gravitational potential energy store, elastic potential energy store, energy transfer examples, right? And work, then we'll talk about efficiency. Yeah. So, to begin with, if I ask you what is energy, if anyone can tell me. Energy is something that, helps you do any kind of work. Without energy, we can't do any work, right? If we briefly define it, this is the ability to do work. You must have observed that when you are not having enough energy, you can't even walk, right? Playing football also requires energy, and running your laptop, of course, it runs on energy. So without energy, you can't do anything. Right? So, energy is the ability to do work, and it is measured in joules. You are aware of that because this is very fundamental stuff. Are you aware that energy cannot be created or destroyed? Energy can only be transferred from one energy store to another. Right, Michael? Danish? Yeah, come on, be active in comment box. I would love to hear from you. Right? This live session is a good opportunity where we can interact. Right? All right. So, energy is needed to keep the appliances. Yeah, good. Appliances and machines working. Right? Okay, so let's begin with the types of energy stores and when we can increase the energy store. That is also something we need to understand. So first is different types of energies, right? Different types of energy store. First is kinetic energy, and you know that this is energy when the object is in motion. Right? When object is at rest, there would be no kinetic energy. When object is moving faster, it has got higher value of kinetic energy. When object is slower, when it is moving slower, it has got less kinetic energy. Right? So it feels good when you interact, and do share this link and let the people more and more join this session. This will give you a different perspective of learning the same topic, which you might have done it earlier, but this this session is going to give you a different perspective. So be there, stay tuned. All right, so I was talking about energy stores. Kinetic energy we talked about. Now we have gravitational potential energy. What is that gravitational potential energy? So I want your attention. If I want to take this pen up above the ground, right? You know what is going to happen when I take this pen upward? I need to transfer some energy, and that energy is working against gravity. You know that gravity is working downward. Gravity would try to pull it downward. But what I am doing it against, right? So the work done in taking it upward against gravity is stored as gravitational potential energy store. I hope you understand this. Come on, tell me in the comment box. Michael, Dennis, Advait. Yeah, are you there with me? Great, very good. Now, there is elastic potential energy. You must have observed that when spring is stretched. Very good. Emmanuel, great. So when spring is stretched, what happens? I transfer energy, then only I can stretch the spring. Right? I am stretching the spring against elastic force, and that is where elastic potential energy comes from. I want you to understand this thing, that when you talk about potential energy, what you are doing is you are changing the position. You are changing the position, right? When I say gravitational potential energy, you are changing the position of object or shape of object against, gravity or elastic force. That is when, gravitational potential energy store is increased when you change the position against gravity. When you change the shape of an object like spring or rubber band or any such kind of springy object against elastic force, the elastic potential energy is increased. Got it? Great, awesome. Now there is chemical energy store. Chemical energy store is found mostly in food, oil, right? Thermal energy store increases when temperature of an object increases, right? Very good. Let's begin with one by one, equations of different energy stores. Very good. This is the kinetic energy. First is kinetic energy. I want your attention. When you are going to determine kinetic energy, you need to talk about two quantities. You need to measure two quantities. One is mass of the object, which has kinetic energy, and the speed with which the object is moving, right? Two quantities are needed in that equation. And the equation is super simple. Half times mass times speed squared. Okay? Come on, tell me, if you have speed or velocity, it will do, both will do in fact. Speed squared times mass, half of that. Half times mass times speed squared. If you can do this question, it would be great. You know the equation? right? Mass is measured in kilogram, speed is measured in meters per second. Mass is measured in kilogram, and speed is measured in meter per second. Go ahead. Try solving it. I'm waiting for your answer. Michael, Advait, Emmanuel, Dennis, come on, give me the answer. Are you able to get that? You need to use the equation is half times mass times velocity squared. Go ahead, do that. Dennis, yeah, so use that, half times mass times v squared, and you know what, energy is given to you. Wow, I'm so sorry about that, Dennis. It started at 6:30. It started at 1 p.m., right? All right, 10-15 minutes. Okay, I got one answer from Michael. Michael, this is incorrect answer. You had to calculate mass, right? I want your attention. Energy is given to you. Energy equals 600 joules, right? Speed is given, right? Speed is also given as 5 meters per second. Using these two quantities, yes, Michael, now use that equation. Kinetic energy equals this, so you have 400 equals half times mass times 5 squared. Tell me what's the answer. Yes, very good, Michael, very good, very good. Go ahead. Now you realized your mistake, get the correct answer. So this would be 800 over 25. Over, Emmanuel Ali is saying 48. Really? It is 32 kg. It is 32 kg, right? Advait, why it is 48? Is that so? Did I do anything wrong? Where are you? Come on, do the calculation correct. Advait, did you get 32 or 48? I got two answers. Why is that? 38. 32, right? Not 48. Okay. Very good. Now, would you please let me know the answer to this question? Yes. So focus on this. At times what happens, you know, in your exams, equations would be given to you, right? Your presence of mind in calculating the correct answer is what for you will be given marks, right? Okay, now do this one. A 10 kg object has kinetic energy of 800 joules. determine the new speed of the object if its kinetic energy reduces to 600 joules. Come on, give me the answer. So mass is given to you, very good. Kinetic energy is given to you. Could you determine the speed first of all? Go ahead. So you have mass 10 kg and you have kinetic energy 800 joules previously, right? And after this you would use this equation, 800 equals half times 10 times v squared. What is the value of speed? With the help of initial kinetic energy, what is the speed? So it would be v equals 1600 over 10, right? 1600 over 10. V squared equals this. So this is 160. So v would be square root of 160, right? Square root of 160. Now the new speed, use the same logic, same concept, you can determine the new speed. Right? Very good, very good. Go ahead, determine the answer. Square root of 160. Right, Advait? It's not 160. Focus on the calculation. Otherwise it will be difficult. Okay, now the new kinetic energy equals 600 joules. So now how would you put the equation? It will be 600 over half times 10 times v squared, and is the new speed, right? This is the new speed, v dash squared. Yes, right. So the new speed would be 1200 over 10 square root of this. So that means square root of 120. Right? Come on. Tell me. Is this the correct answer? Square root of 120. What's the equation for velocity? Alisa, equation for velocity you will get after rearranging the equation of kinetic energy. Kinetic energy equals half times mass times speed squared or velocity squared, right? Is that clear? The velocity is calculated when you rearrange the equation for kinetic energy. Yeah, that's right. That's right. Alisa, did you get that? Did you get your answers? Did you get your answer? Come on, tell me. That's right. So let us move further. Very good, very good. Now let's talk about gravitational potential energy. I had already told you gravitational potential energy store increases when you do some kind of work in taking an object against gravity, right? So here is the equation. Here is the equation where m is mass of the object, g is gravitational field strength, which is 9.8 Newton per kg. This is basically gravitational field strength. Right? H is the height. So when you are taking an object from the ground to this height, the gravitational potential energy increases. How many of you are able to understand this? Great. All right, now I want your attention to this. See, this is very interesting. When you are taking an object upwards, gravitational potential energy increases. When an object is dropped like this, what happens? What happens? Gravitational potential energy decreases. Right, Advait? Emmanuel, Alicia, Michael, all of you need to understand this. If you know it, do let me know, right? The interaction is needed. All right, now I want you to do this question. Go ahead. You need to calculate the decrease in gravitational potential energy when 20 kg ball is dropped from 10-meter height. Right? Go ahead. So, whether you talk about decrease or increase, the equation will remain same. The equation will remain same. So, decrease in gravitational potential energy equals mgh, and there is going to be 20 times 9.8 times 10, and that would be 1960. Very good. Very good, Michael. Very good. Michael, Advait have got correct answer. Would you please let me know what is the unit of energy? Decrease in gravitational potential energy. We all know that energy is measured in joules, so this is going to be 1960 joules. So this is first part of the question. Second part is asking you, when object is falling from a height, which energy store increases? So I want your attention. Right now I'm keeping this pen here. When I drop it, what happens? When I was holding it at this point, the kinetic energy is 0. It had only gravitational potential energy. When I am dropping it, what happens? It begins to move, and due to motion, you know which energy store increases. Kinetic energy increases, right? Is that clear? So when object is falling from a height, kinetic energy increases. Right? Okay. Now, let's talk about this. When an object is thrown upwards, explain which energy store is transferred. So it's very easy. I want your understanding. When you throw an object, you need to provide some velocity to it, some speed to it, with like this. I want your attention here. I'm throwing it upward. When I'm throwing it, I'm giving some velocity. So it had initially, it had kinetic energy store, right? Whatever energy it had, it was in kinetic energy store. Now as it goes upward, when it will start, yes, when it will start, it had only kinetic energy store in it. Now as it is moving forward, moving upward, right, it is going against gravity, so speed decreases. I think you must have observed this. When you throw something upward, while going upward, it has, increasing speed. So when speed increases, when speed decreases, right? Yeah, gravitational potential energy increases because what happens? I want your attention. It is taken to some height. Gravitational potential energy increases. Kinetic energy decreases. So focus on this. I would like you to notice this thing, that at this point, okay, this point C is the topmost point. At the topmost point, the entire energy, at the topmost point, entire energy is GPE. At the bottom, point O, this is point A, B and C. I want your attention, this is very interesting. At the bottom, when you gave this some velocity, you see what, of course that would depend on what are the measurements, mass of the object and height to which it reached, right? So that calculation is there, but I want your understanding. When gravitational potential energy increases, doesn't kinetic energy also? No, it is opposite. It is opposite. I want you to, Michael, I want you to understand this. When you throw something upwards, it is going against gravity and the speed is decreasing. When speed decreases, kinetic energy also decreases. Very good, very good. So at point O, entire energy is in kinetic energy store. At point A and B, it is PE, GPE plus KE. At B also, GPE plus KE. Now at point A, you have, focus on that, Dennis. Dennis, focus on that. At point A, both energy would be there. Entire energy, whatever energy, let's say I'm taking 200 joules. So 200 joules you will obtain at point O, point A, point B and point C. At point C, entire energy will be in gravitational potential energy store. Michael, I would like you to notice this thing. Movement is there, but it is not moving faster. It is slowing down. When an object slows down, kinetic energy decreases. Right? At point A, here it would be more GPE, less KE. This is something that you want to pay close attention to. You need to pay close attention to. Otherwise it will be incomplete concept. Kinetic energy depends on speed. Speed is more, kinetic energy is more. Speed is less, kinetic energy is less. Is that clear? Keep sharing. I know you all are very good, very good. You all are participating. You have this inquisitiveness to learn. That's a great thing. I am really glad. Thank you. Go ahead. Okay, so at point A, you have, more kinetic energy, less GP. At point A, more KE, less GPE. I hope you all have understood this, right? You all have understood this. Great. Now let's move further. Let's talk about elastic potential energy. In any springy object, when you stretch it, you are doing it against elastic force, because what is elastic force? Elastic force will try to bring the object back to its original shape. Right now I want your attention. Look at this. Great, very good, very good. So now this is the equation. Elastic potential energy is calculated as half KE squared. What is K here? K is spring constant, and the spring constant depends on different, right, material. It depends on length. I think you know that the suspension of car has the same logic. The suspension of car and motorbike would be different, right? The car requires suspension and with strong higher value of spring constant. Motorbike would require less value of spring constant, right? Okay, now I want your attention. How do we determine elastic force? It is K times E. E is the extension. K is spring constant. How to calculate elastic potential energy? It is simply half KE squared. Right? All of you have understood this? You're stretching it. There is an extension. You need to calculate that. The spring which you have taken has got the spring constant fixed. That you will take into consideration. And here is one question. I want you to solve this. Would you please answer this question? All right, go ahead. What's the answer? It is half times, I'm saying EPE, right? Half times 300 times 0.4 squared. What's the answer? So 150 times 16 times 10 raised to minus 2. Is that so? Tell me the final answer. Tell me the final answer. Advait, Michael. Why I'm getting different answers? There is one correct answer. Advait, you got 60. Emmanuel got 60 and 24. How is that possible? Come on, give me the correct answer. I have high hopes on you. Come on, you can't make it wrong. Then it goes 24. All right, 24. That's right. 24 joules, right? Very good. That's the correct answer. All right. Now let's move further and let's talk about energy transfer example. What is this? Simple pendulum. Pendulum swings sideways, right? There are two questions. Could you please explain the transfer of energy is taking from which energy store to which? Could you please tell me? When it goes up, it is gravitational potential energy increasing. When it is coming down, kinetic energy store is increasing. When there would be no air resistance, the pendulum continues to swing sideways. When there would be air resistance or some drag forces, the pendulum stops. Right? So when you say pendulum stops, that means there is some energy transfer to the surrounding. Right? There is some energy transferred to the surrounding. When energy is transferred to the surrounding, there is loss of energy. Kinetic energy will be less, potential energy would be less. And ultimately, it would stop. I think you must have observed this. After a while, pendulum stops swinging. How many of you are aware of this? Great, very good, Advait. All right. Now, let's talk about work. When we want to move an object, we need to transfer some energy to that object. Okay? Like this boy is pulling the box. What about the chemical energy that it took to make it move in the first place? So chemical energy, when you are talking about Michael, it was not taken into consideration in this situation. There is no chemical energy that we are going to discuss in this. You have only kinetic energy and gravitational potential energy. But if you would like to understand where this chemical energy is stored, chemical energy is involved in it. So suppose this is the pendulum. It has not yet started swinging. What I would do, I would use my energy, I would use my muscle energy to move this, right? Where do I get this muscle energy from? I got it from chemical energy that I consumed, as food. Food has chemical energy stored. When I consume that food, I built my muscle energy. And that muscle energy I used to move this, right? I took it upward. Then what happened? Gravitational potential energy store increased. And further, when it is falling down, like this, the gravitational potential energy got transferred into kinetic energy. Same thing happens in roller coaster ride. You got to observe that. At the top, you have maximum gravitational potential energy stored. When you come down, at the bottom, you have maximum kinetic energy stored. Right? So this happens in this set of examples. Right? Okay, so let's talk about work. In order to calculate work, you need to calculate what amount of energy you have transferred to the box, to the object. Right, Michael? Without transferring energy, we cannot move an object. Right? Yes, I understood that. That's why I took that point. Very good. Very good, Michael. So I love people who have this ability to get into the fine details of the stuff. That's great. I'm glad, Michael. Very good. It seems that physics is your favorite subject. Very good. Yes, Dennis, you understood without transferring Newton's times. Yes, that's right. Dennis, how do we calculate work? Is, of course, we calculate first force that we are applying times the distance that it moved. One thing is also very important. One thing is also very important. I want you to take into consideration. When you apply the force in this direction, the distance moved, you need to take into consideration in the direction of applied force. I want you to notice one thing, very interesting thing. When a person is holding a box on his head, but he is walking horizontally. I want you to pay close attention to this. Force is acting upward, right? And distance moved is horizontal. In this case, there would be no work done. There would be no work done, right? Come on, are you able to understand that? Michael, Dennis, Advait, Emmanuel, any of you? Come on, tell me. So this is important here, that you need to calculate the distance moved in the direction of applied force, right? So it is calculated as the product of force. Very good, very good. Work equals force times distance. Force is measured in Newton, this is measured in Newton, and this distance is measured in meters. Right? Now, here's the question. Here's the question for you. Come on, give me the answer. Great, very good, very good. Good, good, good. Come on. I'm waiting for your answer, then only I'll go ahead. Come on, give me the answer. So, you need to calculate the work done in moving a box on smooth surface. When I say smooth surface, the friction is absent, right? I will talk about that. There is one question where you were yes, 8,000? Really? Advait, Filsan, Michael, all of you have got wrong answer. There is something, I want your attention. I told you that distance you need to calculate in meters, not in centimeter. So pay close attention to this. Force is 400 times 0.2. When you say 20 centimeter, distance equals 20 centimeter, that would mean 0.2 meters. Is that clear? Are you able to connect to this basic understanding, basic thing? You forgot. Great. So it is 80 joules. Michael, could you relate to that? Why did you use this as meter only in the first place? Okay, focus on that. I had told you distance you need to measure in meters. Very good. Now I have started getting all the correct answers. Wow. Very good. Very good, very good. You are interesting. Okay, now I want you to think properly. There is not much of the calculation in this question, but still it would allow you to think. It would allow you to think. Could you give me the answer to this question? I think you must have observed that when you are moving an object on rough surface, it is harder to move. That means you're required to transfer more energy on the rough surface. Tell me how many of you agree to this? Come on, tell me, how many of you agree to this question? Do we need to apply more? Do we need to supply, transfer more energy? Yes, of course. Answer is yes. We need to transfer more energy. Right? Okay. Read the question carefully. Yes, very good, Michael. So, amount of energy needed to move a box on a smooth surface. Very good. Very good, Dennis. Great. So first part, do we need to transfer more energy? Answer is yes. Determine what amount of total energy you need to transfer to the object to move it on the rough surface if the loss of energy due to friction is 80. So more, you said more. How much more? That's the question. On rough surface, you require more energy. Fine. How much more? That's the question. So on the smooth surface, it was 800. On the rough surface, 800 plus the loss of energy due to friction. That means 880 joules. Come on, is that clear? And when you need to transfer more energy, that means you need to apply greater force. How many of you agree to this? How many of you agree to this? Great, very good. So we need to apply greater force. Just a moment. Give me a second, please. Yeah. So answer to this is yes. Very good. You all are awesome. You all are awesome. You're doing very good. Now let's talk about efficiency. Let's talk about efficiency. You know what? All the machines or devices, appliances are designed to transfer energy. Right? To transfer energy from one form, one energy store to the other energy store. For example, this is electric motor. It is designed to transfer electric energy into kinetic energy. Electric energy into kinetic energy. Now, the question is, do you think that entire amount of electric energy that it takes in, it would be able to transfer to the desired energy store? Answer is no. Can anyone answer to this? Why the appliance cannot transfer entire energy input into the desired energy store? You have all of these appliances, electrical appliances. It is because, I give you an example. Let's take the example of your electric fan. Fan has got electric motor in it. It is designed to transfer electric energy into kinetic energy store. But you know what happens? Entire amount of electric energy is, okay, I'm explaining you. When a device is designed to transfer energy, yes, very good, Michael, very good, you got the correct answer. No device can be 100% efficient. That means, focus on this. It is very simple to understand. Monishagar, come on, focus on this. You would understand this. Suppose a device takes 1000 joule of electric energy and it is designed to transfer it into kinetic energy. 100% efficiency means entire electric energy is transferred into kinetic energy. But that is not the case. What happens? Some energy is transferred into some other forms. Like you must have heard of the sound in electric fan. And when you would touch the fan, you would feel that it got, heated up also. That is why you would say that some energy is transferred to some other form which is undesired energy transfer. right? Undesired transfer of energy. Great, very good. So this is where we define efficiency. Efficiency means the ability to transfer, energy into desired form, right? So it is calculated as the useful output energy transferred by the device over total input energy supplied to the device. And here is the question. Here is the question. I'm sure you would be able to understand this. Electric motor is supplied 1200 joules of electric energy, and it could transfer only 800 joules of energy into kinetic energy store. Right? What is the wasted energy? Wasted energy would be the total energy that it takes in, that is 1000 joules. Sorry, it was 1200, right? 1200 joules, take away 800 joules. 800 joules is the energy that is in the desired format, in the desired form, in the desired store. So 1200 take away 800, that would mean 400 joules as wasted energy. Now question arises, where this 400 joule goes? It goes to heat and sound energy, right? This 400 joule is not in kinetic energy store. It is in 800. 800 is in kinetic energy store. 400 joules is transferred into heat energy and sound energy, right? That is the wasted energy. We do not want that energy, right? That is undesired transfer of energy. Okay, now how would you calculate the efficiency? So it would be calculated as what? 800 over 1200. Come on, tell me what's the answer. Is that so? Is that so? What's the answer? 0.66. Can I say that? 0.66. And if we could convert this into percentage, it is going to be what? 66%. Right? Great, very good. Now, may I ask you, do you have any question? Did you enjoy the lesson today? Yeah, that's right, Michael. Very good. Very good. So, this is the end of the session today. In the next live, we will have some other topic. I hope you enjoyed thoroughly. You have so you can contact with us for all your learning needs. We are known for learning excellence, right? Joyful learning with deeper understanding. Okay? So you can contact us on Telegram channels. You can subscribe our YouTube channel. You can contact us on Facebook also. So stay in contact. Thank you for joining. See you in the next lesson. Take care. Bye-bye.